proposed electrical circuit design presents several issues regarding overcurrent protection, circuit requirements, and wiring practices. The suggestion of using a 15-amp breaker on a circuit with 12 American wire gauge, or AUG, conductor is problematic. A 12 AWG conductor is typically rated for 20 amps, therefore the overcurrent protection should match this capacity. A 15-amp breaker would not provide adequate protection for the 12 AWG wire, potentially leading to overheating or fire hazards if the circuit is overloaded beyond 15 amps but remains below 20 amps. The recommendation that bedroom or living room receptacle circuits only require a 15-amp rating is not correct. Standard practice dictates that general-purpose receptacle circuits in these areas should be rated for at least 15 amps. However, using a 20-amp circuit is not excessive, as long as the wiring and receptacles are rated accordingly. The idea of running a home circuit from the panel to an outlet using 12 AWG wire and then tapping down to 14 AWG wire for the remaining receptacle outlets is generally not a safe or recommended practice. It creates a point of potential failure and violates the principle of consistent wire sizing throughout the circuit. The suggestion would be to use a consistent wire gauge throughout the entire circuit. A recommended alternative circuit design would involve firstly, using 14 AWG non-metallic, or NM, cable for the entire circuit, which is rated for 15 amps. Secondly, using a 15-amp breaker for overcurrent protection. Thirdly, running a home circuit from the panel to the first receptacle outlet and then continuing the circuit to the remaining outlets using the same 14 AWG NM cable. Fourthly, installing 15-amp receptacles on each outlet. There are additional considerations when designing electrical circuits. For example, the proposal to use a smaller breaker to reduce the number of circuits needed in the panel, which is not code compliant or safe. Electrical codes and industry best practices should always be followed, such as consulting the National Electrical Code, or NEC, for specific requirements and guidelines. The NEC provides detailed information on conductor ampacity, overcurrent protection, and wiring methods to ensure safety and compliance. It is important to use properly rated components, such as conductors, breakers, and receptacles, to ensure the electrical system operates safely and reliably. Always consult the latest edition of the NEC for the most up-to-date requirements. The NEC Article 210.21 B1 states that a branch circuit shall not supply receptacles unless they are of the type and ampere rating for the voltage and amperage. For example, a 20-amp circuit can supply 20 amp or more receptacles. The NEC Article 210.21 B3 states that a single receptacle installed on an individual branch circuit shall have an ampere rating not less than that of the branch circuit. For example, a single receptacle on a 20-amp circuit must be rated 20 amps or more. The NEC Article 240.4 D covers the protection of conductors, unless specifically permitted in 240.4 E or G. The overcurrent protection shall not exceed 15 amps for 14 AWG copper, 20 amps for 12 AWG copper, and 30 amps for 10 AWG copper. The NEC Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius in free air. It is important to note that the ampacity of a conductor can vary depending on the insulation type, temperature rating, and installation conditions. For example, a 12 AWG copper conductor with THHN insulation, rated for 90 degrees Celsius, has an ampacity of 30 amps in free air, but it is typically limited to 20 amps in residential wiring due to the limitations of the terminals and devices used in the circuit. When designing electrical circuits, it is essential to consider voltage drop, which is the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances to operate inefficiently or malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or shorten the circuit length. Grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device to trip and clear the fault. The NEC requires all electrical equipment to be properly grounded to protect against electric shock hazards. Grounding can be achieved by connecting the equipment to a grounding electrode system, such as a ground rod or water pipe, and bonding all metallic components of the electrical system together. Arc fault circuit interrupters, or SIs, are devices designed to detect arc faults, which are dangerous electrical conditions that can cause fires. The NEC requires SIs to be installed in branch circuits supplying outlets in dwelling units, including bedrooms, living rooms, and other areas. SIs can detect both parallel and series arc faults and will trip the circuit breaker to interrupt the flow of electricity, preventing a fire from starting. Ground fault circuit interrupters, or GFCIs, are devices designed to protect against ground faults, which occur when electricity leaks from a circuit to ground. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs can detect even small amounts of ground fault current and will trip the circuit breaker to interrupt the flow of electricity, preventing electric shock. Surge protection is another important consideration for electrical systems. Surges are transient overvoltage events that can damage sensitive electronic equipment. Surge protective devices, or SPDs, can be installed at the service entrance or at individual appliances to protect against surges. SPD diverts surge current to ground, preventing it from reaching the equipment. When working with electrical circuits, it is essential to follow safe work practices. Always de-energize the circuit before working on it and verify that the circuit is de-energized using a voltage tester. Wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Never work on live circuits unless you are properly trained and qualified to do so. Proper wiring techniques are also crucial for electrical safety. Make sure all connections are tight and secure. Use wire connectors that are appropriate for the size and type of conductors being connected. Avoid overstripping wires, as this can expose bare conductors and create a shock hazard. When installing receptacles and switches, make sure the devices are properly mounted and secured. Ensure that the wiring is properly routed and supported to prevent damage. Regular electrical inspections can help identify potential problems before they become serious hazards. Inspection should be performed by a qualified electrician who can assess the condition of the electrical system and identify any code violations or safety concerns. During an inspection, the electrician will check the wiring, breakers, receptacles, and other components to ensure they are in good working order. They will also look for any signs of damage, such as cracked insulation, loose connections, or overloaded circuits. If any problems are found, the electrician can recommend repairs or upgrades to improve the safety and reliability of the electrical system. The electrical panel is the central hub of the electrical system. It is important to keep the panel clean and organized. Label each circuit breaker clearly so that it is easy to identify which circuit it controls. Never block access to the electrical panel, as this can hinder emergency responders in the event of a fire or other electrical incident. The electrical system is a complex and critical part of the home. By following safe practices, consulting with qualified professionals, and staying informed about electrical codes and regulations, homeowners can ensure that their electrical systems are safe, reliable, and efficient. In addition, it is also essential to consider the specific requirements of the electrical codes and regulations in the local area. These codes and regulations may vary depending on the jurisdiction and may have specific requirements for wiring methods, materials, and installation practices. It is important to consult with a qualified electrical inspector or local building official to ensure that all electrical work complies with the applicable codes and regulations. The type of load that will be connected to the circuit should also be considered when designing the circuit. Some appliances and equipment, such as motors and transformers, can draw a large inrush current when they are first turned on. This inrush current can overload the circuit and cause the breaker to trip. To prevent this, it may be necessary to use a larger breaker or a special type of breaker that is designed to handle inrush currents. The location of the electrical equipment should also be considered. Electrical equipment that is installed in damp or wet locations must be protected from moisture. This can be achieved by using weatherproof enclosures, ceiling fittings, and grounding equipment. Electrical equipment that is installed in hazardous locations, such as areas where flammable gases or vapors are present, must be explosion-proof. This requires the use of special equipment and wiring methods that are designed to prevent explosions. The NEC provides detailed requirements for electrical installations in hazardous locations. It is also important to consider the environmental conditions when designing electrical circuits. In areas with high temperatures, the ampacity of conductors may need to be deaerated to prevent overheating. In areas with corrosive environments, special materials and coatings may be required to protect electrical equipment from corrosion. Proper maintenance of the electrical system is essential for ensuring its safety and reliability. Regularly inspect the wiring, breakers, receptacles, and other components for any signs of damage or wear. Replace any damaged components promptly. Test GFCIs and FCIs regularly to ensure they are functioning properly. Keep the electrical panel clean and organized. By following these maintenance practices, homeowners can help prevent electrical problems and ensure that their electrical systems are safe and reliable. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. Electricians are trained to work safely with electricity and can ensure that all electrical work is done in accordance with the applicable codes and regulations. Hiring an electrician can save time, money, and prevent potential hazards. It is important to choose an electrician who is licensed, insured, and experienced. Ask for references and check online reviews to ensure that the electrician has a good reputation. Before hiring an electrician, get a written estimate for the work to be performed. The estimate should include a detailed description of the work, the cost of materials, and the labor charges. Make sure you understand the estimate and ask any questions you have before signing a contract. When the electrician has completed the work, inspect it carefully to ensure that it meets your expectations. If you are not satisfied with the work, contact the electrician and discuss your concerns. If you are unable to resolve the issue with the electrician, you may need to file a complaint with the local licensing board or consumer protection agency. The electrical system is a critical part of the home, and it is important to take steps to ensure that it is safe and reliable. By following the information outlined and consulting with qualified professionals, homeowners can help prevent electrical problems and ensure that their homes are safe for themselves and their families. Remember, electrical work can be dangerous. Always prioritize safety.